Okay, welcome to Mechanical Room Mania. Who knows if this will be a thing that we do regularly? Maybe we'll do this once a week, once a month. We're going to do it today. Thanks, Flo the intern, for being our wonderful camera person today. We got young Buck Ryan here. He's going to walk us through
Hello.
Mechanical Room Prefab with CATIA 3D Experience. Let's go. What do we got here?
Alright, so here we got one of our tallwood projects. Basically, UBC residence that's going to be the largest wood structure currently at our filming in 2016. It's pretty exciting. So we're looking at the mechanical room. If I zoom out, this is the first floor. Mechanical room is divided into two sections, so most of the HVAC equipment is in this section. So you got the duct work, and then you have some exhaust duct work in the water entry room. So this is where the incoming water is coming through. You got your RPBPs, your PRVs, your stations, and then over here you got your heat exchangers. And if I zoom in, get in there, you got your air handling units, heat exchangers, pumps, and your maintenance guy for some scale.
Good. Okay, so explain to me, what are the colors? What are we looking at here? Why are all the pretty colors?
So, I mean, obviously this is a construction model, so it's not necessarily representative of the full rendering and materials of the objects, but each of the colors represents a different system. So if you're looking at the ductwork, we have green as the intake or the supply air. We have the red here, the ductwork is exhaust air. Outdoor air is this light blue, and then we got transfer air as this orange. If I hide the ductwork so we can get a little bit of a better view, we have red and blue are obviously water distribution, so cold and hot water. Heating water is this fuchsia / purple.
Very nice,
pink.
fuchsia.
Yeah, you gotta get the color codes right.
Virtual plumber coming with some nice fuchsia colors.
It's very fuchsia-ristic.
Yes.
So,
China blush, one of my favorites.
Yeah, so we have the darker and lighter colors just to represent supply and return, so it's hopefully it's fairly intuitive. Then in this case, since it's a UBC project, they actually have district energy, so we have an orange and a yellow, so supply and return for each of the systems there, and some fire suppression system. So this is the standpipe coming into the stairwells, and yeah, those are the systems.
Good. Okay, so enough about colors. Walk us through the process. So we're going to build a mechanical room prefab on the computer screen and be able to deliver, very precise geometries and cut sheets to pre-cut pipes and prefabricate systems. Mm-hmm. What do you do?
For sure. Well, I mean, obviously you got to start with the structure architectural models, basically a background to work with, kind of identify your constraints. We also were coordinating sanitary on the first floor, so we have the sanitary drainage actually. Sorry, I had that hidden. Good call on that.
And just to clarify why we were modeling the full structure and the architecture ourselves, so in this case it was much easier, but if you're interoperating with other models, you want to have some sort of solid geometry to work with to know where the constraints are in the room.
So normally our sanitary is brown, so there we go. Sanitary is there as well, and all of the pipe is obviously sloped to 1%, 2%, depending on the size of the pipe, so on according to code. But getting into it, we coordinated level 1 sanitary. We started from there, and then by using this as a background, we have all that data for our initial background model. But getting what's built on site and our model to be congruent, we need that as-built data. So we talked to site about getting the column to column dimensions, as well as columns off grid lines to verify where all the columns exactly are, as well as below grade penetration, so where things are coming up from underneath, so that we can connect accordingly when we get into the mechanical room. So that's represented through what we do is we actually build an as-built model. We export an as-built model. So if I click here, you're going to see, sorry, right here, plumbing. you're going to see our as-built for the below-grade sanitary, and this is a dead model, so it can't be modified. This actually tells us the hole is here, and if we were to go into the model and move things around, we know that it can't be changed. All right, so once we have that as-built data, we're getting submittals for equipment, and that helps us build up catalogs and families that we don't already have. So things like what products they're going to use, whether it's welded, Victaulic, what materials, stainless, ductile, carbon steel, and what schedule of piping, so that we have all these catalogs in place. And the thing about building these catalogs is we actually build them all ourselves. So we have all the cut sheets, and we have generic models that we use to use as essentially templates. We link these to design tables which have all of the different parameters, and then we link them also to piping attributes. So stuff like the end style or the flange face, whether it's a raised face or a flat face. Because when you're connecting all these parts together in a spool, you need to ensure that your face-to-face connections are consistent. And we'll get into it a little bit later, but the software will be able to tell us that when we get to that point. So moving on, we also, for these component families, we also embed QA/QC checks. So since we're building all this stuff ourselves, we need to be able to ensure that someone has looked over this at least a second time, if not a third. So what we've done is, if I open up a component family, I'll be able to show you what that looks like. So here's the component family. This is where we build, oh, sorry. I kind of need to have this on this side, right? So here's the component family. This is where we build, for example, a generic flange part. This is a dielectric flange. And if you go inside the attributes here, you'll see that there's multiple ports. So there's a reference attribute which tells you the information and the attributes of the whole part. So you'll have your nominal size, your standard, so on and so forth. But as well as you'll have your port attributes. So this is at the face of the connection. What does that look like? So we'll have end style, so considering whether it's a flat face or a raised face in this case, and what the OD of the pipe is, so that, for example, you're connecting ductile and NPS systems have different ODs. Sometimes if you have the same nominal size but different ODs, the software is going to tell you that you're using the wrong material and the wrong system. That's pretty important in terms of when you're getting into systems with like or buildings with 2 or 3 different systems in them, and you end up using the wrong filtering or the wrong parts.
Yeah, I guess, would you say that this is also beneficial because it's all database driven? So like if you were to do 10 projects and 6 of them have one type of flange and the other 4 have a different, it's just drawing from the database and from these component families, right? So it's somewhat scalable.
Yeah, you're not duplicating any of the data, so they're using that reference part in the cloud and just creating a link. So you're actually saving on a lot of, in terms of like the heaviness or the weight of your model. So that gives you an idea of what that looks like in terms of just adding these attributes and embedding them in, and we use strings to identify that. I'm going to open up the generic model so that you can see what it looks like in terms of additional automation tools that we use when we're building these. So in CATIA, generally there's no one way to do things, and the thing about it is when you're building something, you have to generally draw every single line or every single profile as you need it. Well, what I've done to kind of bring everything together, automate the process, is use the UDF. So for example, one UDF we have is for flanges. Every flange should abide to a certain standard, so when we build these parts, we just embed this flange UDF and link it to all of the nominal sizes and the ratings. That gets you each profile for the flange, as well as all of the data for the thickness, the bolt hole diameter, the number of bolts. So that allows us to recreate every single flange and every single face of an equipment faster and easier and more consistently as well. Another tool that I mentioned earlier is this drawing verification. This is essentially our internal QA/QC check to ensure that someone has looked at this part and reviewed it. So what you'll see is a red light here. And if I go in here and say, okay, I've looked at, just hypothetically, I've looked at this document, I've verified that the part that I'm seeing and the part in the submittal is correct and they match, I'll verify the part. And then this light turns green. What that tells us is that someone has at least taken a second chance to look at it. Now, this is kind of useful in a part-by-part basis, but where it becomes actually the most powerful is when you start getting into an assembly where you have, just like we saw in this model, hundreds of parts. Now, you can't really tell what's been verified and what's not without this check. So if I go into just one system, you're going to be able to see this check analysis. So if I click that, currently there's 0 parts that have been verified.
It's not good, Brian.
So we need Derek, we need Graybeard to be looking over these parts.
Yeah, we need to. And this is actually really critical when you start getting into prefab, because you spend more time up front to make sure that everything is precise from a tolerance perspective. But once you press play, it goes directly to big cut, and everything gets put together like a kit of parts on site. So from our perspective, this is a critical step in terms of QA/QC, and for any piping mechanical trade, this would be huge.
Absolutely. So to be fair, this area of the mechanic room has not been spooled yet. We are pushing the drawings this week, but
we'll cover you some.
Gotta cover ourselves, right?
Right. So keep it going.
Yeah, absolutely. So step 4 is, now that we have all the parts, or most of the parts built, we got to collaborate with the mechanical site super, to basically review their initial thoughts and layouts of the mechanic room.
Yeah, really, you guys are building it together, right?
Yeah.
That's how you're laying it all out, building it in real time in the room together, right?
Yeah, so generally he'll come with some sketches of what he wants to do, what he's thinking. And here's where we start finding real issues, like from the as-built data, we know where the floor drains are, we know where the sumps are, and he's telling us, oh, I want this equipment here, so we need a concrete pad of certain size. So we build that into the model, and right in front of you, you'll see, oh, for example, we found that this sump, so this is the sump, the manhole cover, and we just allocate a surface, and we're finding that initially we had all of these concrete pads in this area, right in this area of the manhole cover. So obviously that doesn't work, and so there's a lot of things that just jump out at you right away. So we can identify those kind of initial issues. Once you have all of the equipment placed and located, you can start doing some initial piping routing. So just getting point A to point B using the schematic, and just basically getting the initial line ID set in place. You can either do this using a PDF schematic that you're provided by a mechanical engineer, or you can actually build this into CATIA, and that's when you can really get some power and some knowledge out of that.
So the linking of the logical and the physical.
Exactly. And then being able to track the flow directions and the nominal sizes and all those attributes that we embedded into the parts.
Good. What's next?
Well, I also wanted to mention, like, when you start doing this massing of the pipe layouts, you also start to get an idea of like the sheer volume of pipe that you're dealing with, and you can start understanding, like, okay, we got certain head clearances or head height clearance that we need to maintain. So, and then you can also identify your zones. So one takeaway from this project is we identified that the heating water systems were more important because we were trying to prevent the use of pressure relief vents. So if you come from a high point and you come down, you ideally don't want to go back down or go back up, because then that requires a pressure relief vent and the drain. You got to find a place to drain, like a hub drain or a floor drain to drain that to. So it gets more complicated, as well as keeping your equipment, if you have like coupled equipment. So for example, this spool right here, we have 2 hot water tanks. Close this verification. We have 2 hot water tanks, and ideally when 2 hot water tanks are connected, you want a symmetric connection. So also using this initial layout to identify whether that's possible or not. Otherwise, you get into a whole myriad of more expenses with balancing valves and so on. So
optimization, you're trying to optimize the layout through the virtual environment.
Exactly, just a little bit, just a tiny bit. So then
it all adds up.
we get all the pipes in there. We move them and massage them around, making sure that we're not getting any clashes.
And you're thinking about maintenance and servicing too, right?
Yeah, so maybe quickly mention that we build in all of these reference surfaces. These are basically door swings, access clearances, whatever is really going to be logical for maintenance, we embed it into the parts. So it's not necessarily a hard surface, and that's why it's transparent, because I mean these door swings, they're not going to be open all the time, but you need to make sure that in the event that they do open, for example,
you'll get access.
Yeah, you'll get access. So from our initial layout, we had these valves at I think 1500 or 1300 above the finished floor, and you can see that that would be in direct interference with those door swings. That's something that pretty hard to tell when you're just looking at a couple submittals, right?
Yeah.
So it was good that we were able to see that and kind of put that up in advance. Oh, and one more thing, we actually also have to add the insulation. So we're accounting for all the insulation of the pipes, and you don't see it here currently just because I have it hidden. I was working on it, but I'll show.
I see you get some insulation.
Yeah, so here we have some insulation.
So basically just reference pulling around the pipe, right? Or is it actual?
Well, it's actual, yeah, so we actually have insulation that is typed exactly like the part fittings. So they have their own like materials, what temperature they're rated for, and what thickness. So we've built that in the master spec as well. So that's all there as well.
That's great.
Yeah.
We're gonna put people asleep here if we don't hurry up quickly with some prefab stuff.
For sure. So
bomb, good stuff.
Yeah. So obviously you have to detail it. So once you get the initial pipes in, we're gonna do a detailing at the station level. So PRV stations, water meter stations. That's gonna tell you whether or not your space, your allocated space, is enough. So for example, in areas like here, am I going to have enough space to fit the minimum straight length required for these water meters, as well as have the space for the PRV station, and then fit that into this little nook in this space. And as you can see, it's pretty tight, especially if you don't want anything in this area of the booster pump. So I even have a little reference model of the guy trying to get back there and accessing that valve.
That's great.
So we have that initial layout, and things will move and change, but once you've kind of got everything and all the pipes, we can get into further detailing. So
getting tired? We're almost there. It's supposed to be a 5-minute video. It's got to be like 20 minutes. You're talking nonstop.
Nothing is ever 5 minutes.
There you go.
So we'll detail the inline components such as water meters, PRVs, strainers, so that we can get an idea of the clearance we need from walls and the clearance we need for access, so on and so forth. And then once you detail that in, you're going to get a model that looks kind of like this. So now we have all the fittings, all the couplings, everything in there, and you can do a last little bit of value engineering in terms of reducing the number of couplings. So if you have valves that need to be on one end of the spool or another, you can move that around, massage that around. Or if you need symmetric pipe work for your threadlets or your instrumentation, then you can move that around and do some value engineering. The biggest gain I think that you're going to get is from welding, right? So a lot of the times we see that you have a fitting and then a piece of pipe and a T, but by doing it all in 3D, you can kind of identify where are the areas where you can just cut that pipe out, move that T over, and move the whole assembly.
Excellent use of threadlets too, I must say.
Threadlets.
Threadlets.
Threadlets and weldelets.
And
yeah.
weldelets.
Weldelets.
Excellent.
So here we got one spool, which is just the water meter and PRV, initial PRV, incoming water PRV spool. And here we have the drawing. So basically we created a spool drawing just for this one small piece of the mechanical room. And this is kind of the final product that we're looking at. So we separate the parts, the actual fittings and specific equipment into one table, and then the pipes and the threadlets into another.
Nominal size, description, and of course this can be customized to any type of standard in terms of how people like to report out.
Yeah, if you have like a certain nomenclature that your company likes, you can modify and build it to those standards, as well as each pipe length, so individual pipe lengths, and then they're all tagged in an ISO view. In this case, what we did is we actually did spool drawings, of course, but also did a piping layout drawing for the hanger locations, as well as station locations, so where they're locating each of the stations in terms of like how far from the wall, so on and so forth.
Mm-hmm.
So
in the future, we should do our hanger tool. We should show our hanger tool.
Yeah, we can definitely.
There's another automation tool that we built in the software for placing hangers automatically. And for a few, we'll do that in the next.
Yeah, I'm sure there's going to be a lot.
Yes.
Yeah, so this is the final drawing.
Okay, and this hasn't been built yet, so we should follow up when this is built. We'll get some live shots.
Yeah, we'll get a quick update.
And so we talked about kind of process, we talked about technology, the database, master spec, we talked about breaking up systems, some value engineering, optimization, and modeling for fabrication, spool, BOM. We link procurement to this, so they're buying directly from the bill of materials, and which can help when you're doing multiple projects, so you can buy out in bulk. If you know you got 5 projects that are going to need a certain system, say Victolic, you can buy in bulk with very accurate level of detail. And then setting up fabrication drawings to ultimately reduce labor cost, or labor risk, I should say, on site, and doing as much on off-site as possible. Anything else you got on that?
Well, I mean, the one thing I would add at the very end of doing this, I think your largest gain is actually being able to use this data again, utilize and reuse all the time and effort that we put into this. So doing building maintenance operations and being able to have all of that data from the submittals, the warranty information, the maintenance installation documents that you need, and that'll also help you with your operations teams in terms of geolocating and identifying, okay, I'm looking for valve 104 in the P&ID. Where's that? Well, we have that all tagged in the model, so you know exactly what system you're working with, what location, what room it's in, and what tools and parts you're going to need from the documentation.
That's great. And then when I was in with GE last week, and they were talking about the digital twin, so the future, linking, live locations with RFID and other types of technology to linking to virtual models, and then having the data talk, which is a future goal for a lot of big companies. That's very interesting. Once you have a true platform, a true database, being able to do that type of analytics and is going to be very powerful. So we've talked about constructability and construction, but the whole operations and maintenance side, which is PLM, was built for that, which is all here. I think we'll use that on another content piece.
Yeah, for sure.
Thank you, Ryan. Thank you, Flo. Maybe we'll do this again sometime if anyone likes this. Bye-bye.